Tutorial sheet 3, question 6. It's a question relating to bandwidth of an FM signal. It says an FM signal has a total bandwidth of 165 kilohertz. When the modulating signal is equal to 10 kilohertz. Estimate the maximum carrier frequency deviation. So notice the word estimate, because bandwidth in FM is an estimation, and the method I'm going to use is using significant sideband pairs. As we know, when we look at the frequency spectrum, if this is the center frequency, the carrier frequency, there are a number of sidebands associated with them. And for bandwidth, one of the mechanisms for calculating bandwidth is that we know what the amplitudes of these sidebands are, because they're related to the Bessel function. And one of the methods is to say, well, when the Bessel function is less than 0.01, then we can ignore it. So that essentially then says we can have a number of significant sidebands which are actually useful to calculating the bandwidth. So what we've got in this case is we have 165 kilohertz, and these significant sidebands are going to be spaced 10 kilohertz apart. So how many 10 kilohertz can fit into 165 kilohertz? Well, obviously that's 16. We haven't got space for a half kilohertz in there, so we've got 16 sidebands, which means we have 8 sideband pairs from that. Now, what we really want to work out is what is the modulation index, because we know the modulation index is equal to delta F over FM. We know what FM is, we don't know at the moment what beta is or what delta F is. However, using the tables, it's difficult to see this, but I'll pull this out of the notes. This is a table of number of significant sidebands against modulation index, and if we look at what 8 is, it's difficult to see, but that does say 5. So what we're going to have is a modulation index for 8 sideband pairs. We get beta is equal to 5. Hence, we can rearrange this equation to give an estimate of delta F approximately equal to 50 kilohertz.